Good evening, friends. Today in this class we are going to discuss this question, that is question number 1 from exercise 1.4. That is, without actually performing the long division method, we state whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. So, how do we will solve this? Here the given rational numbers are: first one 13 divided by 3125, second one 64 divided by 455, and so on. So to solve this question, we have learned one theorem. That theorem we have to make use here. That is, let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers. Then x has a decimal expansion which terminates. So here check whether this rational number whose decimal expansion terminates or non-terminating with repeating decimal expansion. We have to check its denominator. If you take the first example, 13 divided by 3125, then this 3125 can be written of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. If we can write this denominator of the form 2 raised to n into 5 raised to m, let us say that rational number has a decimal expansion which terminates. If we cannot write the denominator of the form 2 raised to n into 5 raised to m, then let us say this rational number has a decimal expansion which is non-terminating but repeat. Here we have to underline the word n and m are non-negative integers, means either be 0 or 1, 2, 3, etc. Non-negative. Okay, so let us discuss the first question. 13 divided by 125. Okay, let us do the first question now. That is 13 divided by 3125. So here the denominator is 3125. If we can write, or if the denominator can be expressed of the form 2 raised to n into 5 raised to m, then let us say it is its decimal expansion terminates. So before to write it is of the form, let us find the prime factorization of 3125. So to find the prime factorization, let us first start by the first prime number 2, but by 2 it is not divisible. Now let us check 3. 3 in 1, 12 is not possible. So the next prime number, let us take 5 in 31, 6 times, remainder 1 in 12, 2 times, then remainder 2 in 25, 5 times, again by 5. So 5 in 6, 1 time, remainder 1, 12, 2 times, remainder 2, 25, 5 times, again by 5. In 12, 2 times, remainder 2, 25 in 25, 5 times, again by 5. So this 5 times. So 3000. Therefore 3125, its prime factorization is 5 into 5 into 5, 5 times, that is 5 raised to 5. So here the denominator, to solve this, so here the denominator is 3125, which is equal to 5 raised to 5. Now, this 5 raised to 5, which can be written as 1 into 5 raised to 5. By multiplying any number by 1, we get the same product. But let us just rewrite it. 1 can be written as some 2 raised to 0. 2 raised to 0 is equal to what? 1. So, this 1 we again rewrite as 2 raised to 0 into 5 raised to 5. Now, it is of the form 2 raised to n into 5 raised to n, where n is equal to 0 and m is equal to 5. See, 2 raised to n and 5 raised to m, where n and m are non-negative. That's non-negative. So, 0 can be possible. So, this 13 divided by 3125 is equal to 13 divided by, now 3125 is 2 raised to 0 into 5 raised to 5, which is of the form and some 13, which is of the form 2 raised to n into 5 raised to n. This denominator is of the form 2 raised to n into 5 raised to n. Therefore, 3125 has a decimal expansion which terminates. Okay. Now let us solve the second one, 64 divided by 455. In a similar way, let us solve. Let us see how we are going to solve this 64 divided by 455. So, let us solve this 64 divided by 455. That is second question. 64 divided by 455. We have to rewrite this 64 divided by 455 of the form 64 divided by 2 sum in the prime factorization of this 455. So let us do the prime factorization of this 455. 455 divided by 2. By 2 it is not possible. Next 3 is also it is not possible. Then let us take 5 by 5 in 45 9 times. Then in 5 1 time. Then again by 5 is not possible. So let us take the next one 7. In 9 1 7 remainder 2 21 3 times. 3 is the prime. So it can be written as 64 divided by 455 is equal to 5 into 7 into 13. So here the denominator is 5 into 7 into 13. Clearly it is not of the form. Clearly it is not of the form 2 raised to n into 5 raised to m. Here it is 5 into 7 into 13. So it is clearly not of the form 2 raised to n into 5 raised to m. So if it is not of the form 2 raised to n into 5 raised to m, then this rational number has a decimal expansion which is non-terminating but repeat. So, the rational number (64 divided by 455) is non-terminating repeating repeat. Its decimal expansion is non-terminating repeat. Now let us check the third one. 29 divided by 343. So we have to find the prime factorization of 343. Let us check. By 2 not possible, 3 not possible, 5 not so. Let us check by 7. In 34, how many times 7 goes? 4 times, right? 4 7s are 28. 28. So reminder, 6 in 63, 9 times. 40 again by 7. In 49, 7 times. So it can be written as 29 divided by 343 is 7 into 7 into 7. So 7 cube. Clearly again, here the denominator is 300 is 7 cube. 343 which is equal to 7 cube. Clear, obviously it is not of the form. It is not of the form 2 raised to n into 5 raised to n. So the rational number 29 divided by 343 whose decimal expansion is non-terminating and repeat. Non-terminating and repeat. Now let us consider this fourth one. It is 23 divided by 2 raised to 3 into 5 square. Fourth one. 23 divided by 2 cube into 5 square. Here the denominator is 2 cube into 5 square. Here the denominator is given in the prime factorization itself. So no need to factorize the denominator now. But and it is very clear it is of the form 2 raised to n, some 2 raised to n into 5 raised to m, where n and m are non-negative integers. So here denominator is 2 raised to 3 into 5 raised to 2, which is of the form some 2 raised to n into 5 raised to n. So the rational number uh, 23 divided by 2 raised to 3 into 5 square has a decimal expansion which is terminate. Clear? That is, since it is of the form, the denominator is of the form 2 raised to n into 5 raised to m. This rational number has a decimal expansion which is terminate. Now let us see the last one. Fifth one. 129 divided by 2 raised to 2 into 5 raised to 7 into 7 raised to 5. Here let us check the denominator. Here the denominator is 2 raised to 2 into 5 raised to 7 into 7 raised to 5. Let us check whether it is of the form sum 2 raised to n into 5 raised to m. No, it is not of the form 2 raised to n into 5 raised to n. Here it is 2 raised to 2 into 5 raised to 7, then some extra 7 raised to 5 is there. So, since it is not of the form 2 raised to n into 5 raised to m, let us say this rational number has a decimal expansion which is non-terminating and repeat. So, the rational number (129) divided by 2 square into 5 raised to 7 into 7 raised to 5 has a decimal expansion which is non-terminating and repeat. So let us discuss these types of question, or without doing the actual long division, let us, by using this, recalling this theorem, let us say whether the given rational numbers are, or whether the given rational numbers has a decimal expansion which is either terminating or non-terminating and repeat. So to decide it, to determine it, we make use that theorem that x is equal to p by q, where is a rational number such that the expansion of q is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers. Then the rational number has a decimal expansion which terminates. If it is not of the form 2 raised to n into 5 raised to m, then rational number has a decimal expansion which is non-terminating and repeat. Okay, so thank you.